go to Edit, Preferences, Get Extensions, search for Cell Fracture, and then click the Install button. Select your object, go to Object, go to Quick Effects, and then Cell Fracture. This will bring up a bunch of options here. The most important one, I don't know what most of these do to be honest. The most important one is going to be source limit. This is set by default to about 100. We probably don't need 100 individual fracture pieces. So I would recommend lowering this to something like maybe 25 or so. Click OK. This will generate your fractured mesh. Now that we have all of our pieces, we can export as the FBX. And to show that it also works on this anvil here, you're going to go to Object, Quick Effects, Cell Fracture, Source Limit, about 25, click OK, and now we have a broken anvil with individual broken pieces. This will be using Unreal Engine 5 blueprints. However, I do believe the theory can be used in any game engine of your choice. The next thing you'll want to do is drag in your FBX file with your broken pieces. You want to create your blueprint class, actor, name it BP underscore breakable vase, add a static mesh, call it vase mesh, select your static mesh in this menu. Under vase mesh, search under details, search physics. I have simulate physics. I have a mass of 100. This is to prevent small physics glitches, essentially. Mainly that's what it's for. But you can set your mass to whatever, or you can leave this unchecked. Next in the event graph, this will of course be BP underscore breakable vase. This is the actual vase object that you're placing into the level. First thing you're going to want to do is to create a float variable. Call it HP or health. I have this set to 1 so that anything, regardless of your damage, can break it. We're going to bring in any event, any damage node, and then we're going to set the HP to the HP minus the damage. We're going to check, is this less than or equal to 0? If it's true, we're going to break. What's break? Break is a custom event. First, we're going to play a sound at the location of the vase mesh. This is the break sound. The next thing we're going to do is we're going to spawn this BP vase broken. What you're going to do, you're going to make a new blueprint class, actor, name it BP underscore vase broken. Go to where you put your broken pieces mesh, select them all. And then click static mesh. You'll see here it says multiple assets. Click that, it will add all the assets. Under details, go to search. Select simulate physics, and for this I like to put the mass at 50. If you drag this into the world, as it is normally, every single one of these pieces will have physics and collisions. They'll have collisions with each other, so once you spawn this BP underscore vase broken, it will explode violently in a way that you probably don't want it to do. The important thing here is to select physics body and select ignore. Your collision preset's set to custom, because if it's set to anything else, it'll be grayed out. So select custom. We want to ignore pawn, and we want to ignore physics body. What ignoring physics body does is these pieces won't collide with each other, so they'll just pass right through each other. This is important because at frame 0, whenever we spawn this, and when you have a bunch of physics objects overlapping each other, you're going to have a physics explosion. In BP vase broken here on event begin play, we're going to do a for each loop. We're going to get components by class, component class type, static mesh component. We're going to put that into the for each loop in array. Through loop body, we're going to add impulse, drag out your array element into target. If you don't check velocity change, your pieces might not fly around. We're going to make vector. So just right click, type make vector. It'll make one of these nodes. Go ahead and plug the return value into impulse. And then for X, Y, and Z, we're going to get a random float in range. 3 random floats in range. For X, we have minus 300 to 300. We're going to do the same for the Y. For the Z, we don't want a negative value for the minimum for the Z, because we don't want them to fly down. We want them to fly up. So minimum 100 to 600 is what I have here. For a little bit of extra juice, we're going to add angular impulse in degrees. The target is going to be the array element. For X, I have minus 300 to 300. For Y as well, and for Z. And that's going to plug into a make vector node into the impulse. What this does, this will make the pieces spin. And the important performance part, after this for each loop is completed, I'm going into a delay of 10 seconds. You can put whatever you want right here. And then we're going to just destroy the actor. Say you break 5 pots, suddenly that's 25 times 5 pieces lying around. So after 10 seconds, we're just going to destroy the actor. We don't have to drag in the array elements or anything. Destroying the actor will destroy every single cell here. Okay, back to breakable vase. Now that we have the vase broken, this is the vase in its broken state, we can spawn it. We want to get the vase mesh here, and we want to get world transform. So just drag out and type get world transform. And then we're going to plug this orange output into the spawn transform. For class, make sure to set it as your BP vase broken. And then you're going to drag out and you're going to destroy actor. This will destroy this vase. We don't want this vase anymore. Once you destroy this vase, it's going to be gone. And that's what happens in the break event. If you want to give money as well, you can make a reward money function. This will require additional setup that's outside of the scope of this video. Go ahead and compile and save both your blueprints. As an extra bonus, if you select your vase mesh, type hit here, do simulation generates hit events, check that to true, and then take out the vase mesh. On component hit, whatever hits this physics object, the vase mesh, it will trigger this. Get your vase mesh, get the component velocity, get the vector length, and then see if it's greater or equal to a certain value. I have 300. You can experiment with this value to see what you like the most, but I've found 300 works very well. Drag this boolean into the branch, make sure you compile and save all your blueprints. And this is what it looks like if everything's wired correctly. The pieces fly around because of add impulse. They spin in the air because of another add impulse. These are physics pieces that the player does not collide in. You can see there it broke because something hit it at a high speed. But throw it, breaks. Throw it, it breaks.